So welcome to my YouTube channel. Today I will discuss a very important chapter, that is solvation of differential equation by the help of power series method. So let's start. Solving DE by power series method. So we basically solve differential equation of order 2 here. So what is power series? Let us define this first. What is power series? So power series definition. So a series, an infinite series of the form sigma Cn into x minus x naught the whole to the power n is running from 0 to infinity, is an integer, is called power series in x minus x naught, or it is called the power series about x is equals to x naught. So the infinite series sigma Cn x minus x naught whole to the power n is called the power series in x minus x naught, or it is called the power series about x is equals to x naught. So both are same. So sigma Cn x to the power n from 0 to infinity is a power series about x is equals to 0, or is called power series in x. So now we will discuss about the power series which is convergent or divergent. So convergency and divergency of this series depends on a terminology, which is radius of convergence. So this power series will converge in a certain neighborhood of x naught. So radius of definition, radius of convergence. Radius of convergence. What is radius of convergence? R, we call R is radius of convergence, which is equals to limit n goes to infinity Cn by Cn plus 1 is an absolute limit of the term Cn by Cn plus 1. If it exists, if this limit exists, then R is called the radius of convergence of this series. If it exists, then R is called the radius of convergence. If we call this as 1, radius of convergence of 1. Okay. And also x naught minus r to x naught plus r is called, same term, is called the interval of convergence. Interval of convergence of 1. Interval of convergence of 1. So for this case, minus r to r is the interval of convergence. So the same terminology, the radius of convergence or the interval of convergence, same. Now let us define another important definition, which is analytic function. Analytic function. What is analytic function? Very important. Let x naught belongs to the interval of convergence. X naught is a member, is a point in the interval of convergence. Point in the interval of convergence. A function fx is said to be analytic. Analytic function কোথায়? At x is equals to x naught. If there exists a neighborhood, of x naught in which fx is differentiable. Here in different TIA BLE, differentiable. Or it is differentiable, or sigma f in x naught divided by factorial n into x minus x naught whole to the power n from 0 to infinity. This infinite series converges to fx. That is, this is the Taylor series expansion. This Taylor series, if converges to fx, then we call the function is differentiable at fx, at x is equals to x naught. Then fx is differentiable. Fx is differentiable at x is equals to x naught. So now, give an example of analytic function, or which is, and also cite an example which is not the analytic function. So give an example. All the polynomial function e to the power x, sin x, cos x are analytic, etc. are analytic everywhere. Analytic everywhere in R. A rational function fx by px is analytic everywhere except for those points x for which px is equals to 0. So the denominator, if denominator is will vanish for some points, then for that point the rational function is not analytic. So if we take hx is equals to x by something like x square minus 3x plus 2. This is equals to, we call x minus 2 into x minus 1, and so for x is equals to 1, 2, hx has infinite discontinuity. Hx has infinite discontinuity. So hx is not differentiable at x is equals to 1 or 2, and hence is not analytic. Hence is not analytic. It's not analytic. So now we define an important definition of ordinary point. Ordinary point of DE. So let us take the differential equation let us take the differential equation y double dash plus px into y dash plus qx into y is equals to 0. Is a second order differential equation. A point x is equals to x naught belongs to x is equal to x naught is called the ordinary point of this DE differential equation if Px and Qx are analytic at x is equals to x0, x naught. So both Px and Qx are analytic at x is equals to x naught, then x naught is called the ordinary point of this DE. Let us cite an example. 2x square d2y dx2 plus 7x into x plus 1 dy dx minus 3y is equals to 0. So equals to 0. So we rewrite this as d2y dx2 plus 7 into x plus 1 divided by 2x. We cancel 1x into dy dx minus 3 divided by 2x square into y is equals to 0. Then x is equals to 1. If we take x is equals to 1, then it is no discontinuity at x equal to 1. So we are Px, if we compare, so Px will compare with this, then Px is equals to 7 into x plus 1 divided by 2x, and Qx is equals to minus 3y 2x square. So both Px and Qx are defined at x is equals to 1. So x is equals to 1 is an ordinary point as Px and Qx are differentiable there. But if we take x is equals to 0, but if we take x is equals to 0, then Px and Qx has infinite discontinuity. So x is equals to 0 is not an ordinary point. So x is equals to 0 is not an ordinary . So now we give another definition. We give a definition which is not ordinary point. It is called singular point. So a point which is not ordinary is called a singular point. So let's write a singular point. Singular point. A point x is is equals to x naught is called singular point of the DE if it is not an ordinary point. It is not an ordinary point. Singular point is of two types. Singular point is of two types. One is a regular singular point and other is irregular singular point. So what is regular singular point and what is irregular singular point? Regular singular point. A singular point x is equals to x naught is called regular a regular singular point is called a regular singular point if x minus x naught into px, that given d, if we also write this d2y dx2 plus px into dy dx plus qx into y, those px, so x minus x naught into px and x minus x naught plus square into qx are analytic. Both are analytic at x is equals to x naught. Then we call that x is equals to x naught is a regular singular point. So both x minus x naught into px and x minus x naught plus square into qx are analytic at x is equals to 0. Then we call x is equals to x naught is a regular singular point. So for this example, if we take this example, so px is equals to, so we write this 7 into x plus 1 into 2x and qx is equals to minus 3 by 2x square. We already see that x is equals to 0 is not an ordinary point, so it is singular point. Now, so x minus 0 into px is equals to x, px is equals to x into 7 into x plus 1 by 2x, so x cancel out. So this is 7 into x plus 1 by 2, which is analytic at x is equals to 0. Analytic at x is equals to 0. And x minus 0 whole square into qx, this is equals to x square qx, which is x square into minus 3 by 2 x square, this is minus 3 by 2, analytic at x is equals to 0. So x is equals to 0 is a regular singular point. So x is equals to 0 is a regular singular point. And a definition: irregular singular point. Irregular singular point. So which is not regular? A singular point x is equals to x naught is which is not a regular, which is not a regular singular point is irregular singular so if those px is 2x square, if the px is 2x square, then x into px will be 2 by x, so x is not analytic there. And if this is 3 by 2x cube, then it is not analytic at x is equals to 0. So those who are not a regular singular point is called the irregular singular point. So this is the today's topic. Hope you are enjoying, and if you want to see more math, please subscribe my channel and inspire me to do something like these videos. So thank you.